Hello students, this is some additional material to the lecture regarding the complex numbers. So you will see the examples we had covered in class and any other additional material which comes to my mind. So let's get started. So our first example in class was w squared equals 1. Now according to the fundamental theorem of arithmetic, this equation has exactly two solutions, which may or may not be equal to each other, but this time they won't be. I will have to extract square root, so I will write down the formula that I have previously learned. The formula, as you can see, is the following. The nth root of complex number z equals the nth root of its modulus times cosine phi, which is the argument, plus 2 pi k divided by n, plus I times sine phi plus 2 pi k divided by n, where k is an integer ranging from 0 to n minus 1. Oops, I ran out of space, but now we can see it. So this is the general formula. And obviously, if I want to substitute the correct values, I will have to write -1 as a complex number. So for that, I will draw this number in the complex plane. I know it sounds unbelievable, but these lines are both straight. So here I have the vector representing the complex number -1 plus 0 times I. I need two pieces of data. The first is the magnitude of this vector, or the absolute value of -1. I know that this is 1. And I also need the argument, which is the angle between the vector and the positive half of the horizontal axis. This is 180 degrees, or in radians it's pi. So I can write the formula in this concrete form, not in general. So the square root of -1 is the square root of 1, which we will calculate shortly, times cosine pi plus 2 pi k divided by 2 plus I sine pi plus 2 pi k divided by 2, and in this particular case k can be 0 or it can be 1. So we will have the two solutions to this equation. The first one is the case of k equals 0. So w0 is the square root of 1 is 1. So 1 times cosine pi plus 0 divided by 2, so cosine pi half, plus I times sine pi half, which can be calculated. The cosine of pi half is 0, the sine of pi half is 1. So this complex number is 0 plus 1 times I, for short, I. Let's see the other solution. So k equals 1 this time. W1 equals 1 times cosine pi plus 1 times 2 pi, that is 3 pi divided by 2, plus I sine 3 pi by 2. And this can also be calculated. The cosine of 3 pi over 2 is 0. The sine of 3 pi over 2 is -1. So this number is 0 minus 1i. For short, -I. And if I want to check my solution, let's substitute them into this equation. First, w0. I squared is by definition -1, so this we are sure is correct. Negative I squared, well, let's calculate it, shall we? Negative I squared is negative I times negative I. Negative times negative is positive, so this is I times I, which is I squared, by definition, negative 1. So this was the example 1, and we will move on to example 2 in the next video.